Okay, this is section 4.2, standard form of quadratic function. So our objectives for this section: graph a quadratic equation in standard form, identify the vertex and axis of symmetry, determine the maximum value, expand vertex form into standard, and use completing the square to convert standard form into vertex form. In section 4.1, we were introduced to the idea of vertex form. So vertex form was f of x equals a times the quantity x minus h quantity squared plus k. And vertex form was really nice because we were able to identify the vertex and the axis of symmetry very quickly through transformations. Today we're going to talk about standard form, ax squared plus bx plus c. And this one's going to take a little more work. So what you'll notice here is, in order to find the vertex, it's going to take a little bit of calculating. So to find the x coordinate, we do negative b over 2a. And then whatever the x coordinate is, we put that number into the function in order to find out what the y value of the vertex is. And so once we have that, the axis of symmetry is still x equals whatever the x coordinate of your vertex is. Okay, so let's take a look at that. So to calculate a y-intercept of any function, you're going to substitute in 0 for x and you're going to solve for y. And that's because the y-intercept is always the ordered pair 0 something. So if you let x equal 0, you will always find the y-intercept. Okay, so number one, the first thing we're going to do is we are going to start off with our vertex. So ax squared plus bx plus c. So first thing, I'm going to identify what is a, b, and c. So in this case, a is 1, b is negative 4, and c is 7. So once I know that, I'm going to do negative b, so that's negative negative 4 over 2 times a, 2 times 1. Negative negative 4 is 4, so 4 divided by 2 is 2. So that number does two things for me. The first thing it does for me is it gives me the x coordinate of the vertex. And the second thing it does for me is it gives me my equation for the axis of symmetry. So I have those two things done. Now that I know that my x coordinate is 2, I need to figure out what f of 2 is. So what I do is I substitute in 2 for x into my function to get the y coordinate. So 2 squared is 4, 4 minus 8 is negative 4, and negative 4 plus 7 is positive 3. So what that means is my y coordinate is 3. So if I take a look at my graph, if I go to 2, 3, that is the location of my vertex, and there is my axis of symmetry, the vertical line that goes right through it. Okay, now that I know that, I can do my domain. My domain is all real numbers. Okay, if I want to do the range, first thing, because my a value is positive, I know that my graph opens up. So my vertex is going to be a minimum value because it is the lowest point. So it has a minimum value of 3 at x equals 2. That also helps me with my range. Because it's a minimum, my y value is the lowest value. It's the minimum. The maximum value is up to infinity. All my y values are greater than or equal to 3. So that's how I would do my range. My y-intercept is what happens when x equals 0. So that is actually quite easy because when you put in 0 for x, you get 0 minus 0 plus 7, which is just 7. So my y-intercept is located at 0, 7. So if I go to my graph and I plot 0, 7, I get that point right there. Now the nice part about parabolas is they are symmetrical. So what you'll notice is 0, 7 is 2 units away from the axis of symmetry. So because it's 2 units away from the left of it, it's also going to be 2 units away from the right at the same height level, which is at 4, 7. So that's one thing that I can do in order to make my life easier as far as symmetry is concerned. The 1a, 3a, 5a still applies here. So in this case, a is 1. So 1 times 1 is 1. 1 times 3 is 3. 1 times 5 is 5. So I'm going to be going up. So from my vertex, when I go 1 unit right, I go 1 unit up. When I go 1 more unit right, I go 3 units up, which is already accounted for. So that's how I know that I'm doing the right thing here. Okay, and then I just create the symmetry I draw in my U shape, and there's my graph. Okay, so I started off with the negative b over 2a, and I went from there. So what I want you guys to do is I want you to try number 2. Okay, in this case, just to make sure, we start off on the same. A value is negative 2, B value is negative 4, C value is negative 5. So let's try number 2, and then also turn the page. Let's try number 3 as well. Okay, so pause here, and let's give 2 and 3 a try. Let's see how we do. Okay, let's see how we did on numbers 2 and 3. So I'm starting off with negative b over 2a. So I have negative 4 over 2 times negative 2. So negative 4 is 4, and then I have 4 over negative 4, which is negative 1. So my axis of symmetry is x equals negative 1. My vertex is negative 1 something. I am going to have to find f of negative 1. So I have negative 2 times negative 1 quantity squared minus 4 times negative 1 minus 5. Okay, so order of operations, I have negative 2 times 1. Negative 4 times 4 is plus 4 minus 5. So negative 2 plus 4 minus 5. That leaves me with 2 minus 5, which is negative 3. So that is the y-coordinate of my vertex. Okay, my a is less than 0, so I know my graph opens down. So my vertex is at negative 1, negative 3. So my domain is all real numbers. This is going to be a maximum value. So my maximum is negative 3 at x equals negative 1. My range, because it is a maximum, that is the largest value I can hit. The smallest will be negative infinity. The y-intercept, f of 0, is going to be negative 2 times 0 squared minus 4 times 0 minus 5. So in this case, you're just left with negative 5. Okay, so if I plot my vertex, negative 1, negative 3, I am down here. I am also at 0, negative 5. My axis of symmetry goes right through my vertex. 1a, 3a, 5a, where a is negative 2. So that's a negative 2, negative 6, negative 10. What you'll already notice is as I go 1 unit to the right, I go 2 units down. That's the y-intercept. And I mirror it to the other side. Okay, the next one is 6 units down. So 1, 2, 3, 4, 5, 6 is over here. And then 6 will be over here. And then there is my parabola. Okay, so that would be number 2. Number 3, okay, my a value is 1, my b value is negative 2, my c value is 3. Negative 2 over 2 times 1. So this is 2 over 2, which is just 1. Axis x equals 1, vertex is 1 something. I want to find f of 1, so that's 1 squared minus 2 times 1 plus 3. So 1 minus 2 plus 3, I'm looking at negative 1 plus 3, so positive 2. So my vertex is at 1, 2. My a value is positive. I'm opening up, so my vertex is at 1, 2. That means that I have a minimum value of 2 at x equals 1. My domain is from negative to positive infinity. Because it's a minimum, 2 is the lowest value, infinity is the highest. My y-intercept, what you should be noticing now is this. My y-intercept, 0 squared minus 2 times 0 plus 3. Every time you put in a value for x, all the zeros for x, everything cancels out. What you should be noticing now is this. Your y-intercept is 0, comma c, your constant. Your constant 3 is your y-intercept. If you go back to the previous problems, your constant negative 5 was the y-intercept. Your constant 7 was the y-intercept. So whatever your constant is, that's your y-intercept. Okay, so now that we've discovered that, I'm at 1, 2. There's my axis of symmetry. Okay, 1a, 3a, 5a. My y-intercept is at 3. A is equal to 1. So that's a 1, a 3, and a 5. As I go 1 unit right, I go 1 unit up. When I go 1 unit right, I go 3 units up. 1, 2, 3. Okay, and then I will just bring this down, curve it, and make my U shape like that. So there's my graph. Okay, so hopefully you guys are picking up on this pretty quickly. Okay, the next one, we're going to write in standard form. So we've practiced this in our Delta Math before. So standard form, y equals ax squared plus bx plus c. So for number 6, order of operations, this just means I have x minus 4 twice. When you try to FOIL this, first, outer, inner, last, what you're going to notice is you can do outside and inside together. This is just a minus 4 and another minus 4. Minus 4 and minus 4 makes minus 8, so minus 8x. Plus 16 plus 5. So therefore, I have y equals x squared minus 8x plus 21. And so this would be my answer in standard form. Okay? So let's have you guys try numbers 7, 8, 9, 10. Try these 4 problems. You do FOIL, you do distributive property, and then you simplify. So pause here, give it a try, write it in standard form. Okay, let's take care of 7 and 9 first, and then we'll switch over to the left side second. So I have x plus 3 quantity squared, which means that I have 2 of them, x plus 3, and then plus 7. So when I FOIL it, I have x squared plus 6x plus 9, and then plus 7. So therefore, y equals x squared plus 6x plus 16. For the second one, you're going to FOIL first. So when I FOIL it, x squared plus 9x plus 20, and then I'll distribute the 2 second. So 2x squared plus 18x plus 40, and that would be my standard form. Okay, so what we're noticing here is this. Okay, we're going to work backwards in a moment, so I just want to kind of call attention to this. If I gave you the standard form, what you'll notice is you can take the constant and you can rewrite it as the sum of 2 values. Now, the sum of the 2 values that you use, one of them makes a perfect square trinomial, which can be factored down into x plus 3, which takes you to x plus 3 quantity squared. So when we go from standard to vertex form by completing the square, we're just working our way backwards to the beginning there. So we're going to break the constant apart and then go from there. So I'm just kind of preparing you for what you're going to see. Okay, so let's take a look at number 8 and 10. So for number 8, we're going to FOIL first. So I have 2x minus 1, minus 2. I'm going to FOIL, so that's x squared minus 2x plus 1. I'm going to distribute 2x squared minus 4x plus 2 minus 2. And then the last thing is simplify, 2x squared minus 4x. And that would be it. Okay. This last one, I'm going to save the negative sign. I'm going to FOIL x squared minus 9x plus 14. And then I'm going to distribute negative x squared plus 9x minus 14. And that would be my standard form there. Okay, so that's going to go from standard from vertex to standard. And now what we're going to do is we're going to talk about going from standard into vertex by completing the square. Okay, so step number 1, we're going to try go the other way now. It says make sure the leading coefficient is 1. So the leading coefficient definitely is 1. So we're going to rewrite the entire equation with the 6 moved over to leave space. So x squared minus 4x plus 6. Okay. I'm going to find b over 2. So my b value is negative 4. I'm going to cut it in half. That's negative 2. And I'm going to do b over 2 squared. and that's going to give me 4. I'm going to add its square. So what's going to happen is this. This 4 completes the square. That's what the b over 2 squared does. But because I am adding 4 to one side, normally when we were solving, what we would do is we would add 4 to one side, and then we would add 4 to the other side in order to keep it balanced. Another way to keep it balanced is this. If you minus the 4 to the other side, so if you add 4 to one side and subtract 4 to the same side, you're still balancing out. If you gain 4 and you lose 4, you didn't do anything. So because I plus 4, I'm also going to minus 4, like that. Okay, so by doing so, I can factor this. The factors of 4 that add up to -4 are -2 and -2. So what that means is that trinomial becomes x minus 2 quantity squared. The remaining piece, 6 minus 4, becomes plus 2. So this factors into x minus 2 quantity squared. This became this. And this plus 6 minus 4 became this. Okay? Once I'm in this form, we know something. We know the vertex. It's going to be at 2, 2. We know the axis. It's going to be x equal 2. Verify it by calculating the vertex. So, calculating the vertex means using the standard form. I'm going to start off with negative b over 2a. So that would be negative 4 over 2 times 1. So that's 4 over 2, which is 2. So that first part, that's good. So now what I'm going to do is find f of 2. So that's 2 squared minus 4 times 2 plus 6. So this is 4 minus 8 plus 6. So 4 minus 8 is -4, and -4 plus 6 is 2. So when I put in 2, I get out 2. That's why I know that my vertex is correct at 2, 2. So that's how I would use completing the square. Okay, now the little more complicated ones is when you have to factor things out. Okay, so for example, if you take a look at number 12, we don't want the 4 there. So what we would have to do is we would have to factor out the 4 by dividing it. So when you divide by 4, that leaves you here. Okay, now what happens is this. Your b value is 7 over 4. When I cut it in half, that means 7 over 4 times 1/2. That's 7 over 8. And when I square that, 7 times 7 is 49. 8 times 8 is 64. That is the number that completes the square. So the 49 over 64 will go here. The one thing you have to caution is this. The mistake is that you're going to say minus 49 over 64. What you're missing is the fact that we factored a 4 out. We divided by 4 to begin with. So therefore, when you want to account for it, you have to multiply it by 4. So 49 over 64 times 4. We're going to redistribute the 4 here. Now, 64 is divisible by 4, so I'm going to reduce. So 4 goes into 64, and so 4 goes into 6 once. That leaves you with 24, so it leaves you with 16. So that means that this is equivalent to 49 over 16. Okay? The 4 is still there. This is x plus 7 over 8, quantity squared, minus 49 over 16. The reason I knew it was plus 7 over 8 was because the b over 2 is always the one that goes in the middle. Okay? The last one, so because this is in vertex form, the vertex is going to be located at -7/8, comma, -49 over 16. If this doesn't make sense to you, you still have the negative b over 2a version that you can do, and then simplify it from there. Okay, for the next problem, same thing. I'm going to start off by factoring out a -2. So when I factor out a -2, I get x squared and then minus 4x. And then I still have the plus 3 out there that I don't need. My b value is -4. When I half it, it becomes -2. And when I square it, that becomes +4. So this plus 4 is going to go right there. But again, when you put it back in, you didn't actually add 4. There's the -2 that you factored out. So I have to take the 4 and I have to multiply it by the -2 to make -8. So that's really what I need to do. I'm sorry, this needs to be +8 because 4 times -2 is -8. So therefore, in order to undo that, I have to add 8. So that keeps it balanced. Okay, so now I have y equals -2 times the quantity x minus 2 squared plus 11. And this would be vertex form. But again, if the completing the square version is not working for you, you still have the -b over 2a, and you can still calculate it that way, and you will be perfectly fine. Okay, so that would be it for this section. Main takeaway is, can you identify the vertex once you are in standard form? And then once you have the vertex, you can go ahead and graph it. Okay, good job. That's it for this section.